Hi there, welcome back to TechnoWorks. Pump speed is the most essential parameter, since it governs not only the pump size, but also the pump life cycle cost. For a particular pump rating and configuration, more than one operating speed may be commercially available. Each of these commercially available speeds results in a different pump size as well as a different initial cost, operating cost, and maintenance cost. A higher speed pump is desirable because it results in the smallest size of pump and motor set. It can be understood using affinity laws because a small diameter impeller must rotate at a faster speed to meet the given duty condition than a larger diameter impeller at a slower speed. Another benefit of small size is that it requires a thin wall to contain system pressure, resulting in the lowest initial cost. However, selecting a pump with higher speed requires a higher net positive suction head. Hence, the pumping system has to be designed for a higher net positive suction head, which increases the fixed cost. Generally, pumps with higher speeds have more wear and tear as compared with slower pumps, therefore, higher speed pump configurations have a higher maintenance cost. Now, I will show you how to select the pump speed. As per Hydraulic Institute standard, pump suction specific speed can be used to estimate maximum operating speed. This equation may be used to calculate the maximum operating speed. In this equation, N is the maximum operating speed in RPM, Q is the volumetric flow rate in cubic meters per second, NPSHA is in meters, and NSS is the suction specific speed in metric units. The Hydraulic Institute standard recommends a suction specific speed of 165 in metric units, which is equal to 8,500 in US units for calculating the maximum operating speed. Alternatively, this graph can also be used to calculate the maximum operating speed for a given pump flow and available net positive suction head. Pump specific speed influences the highest attainable efficiency of a pump, and for a given flow and head, the specific speed is the only function of pump rotational speed. As this graph shows, increasing the specific speed improves the maximum attainable efficiency. This chart also indicates that the bigger the pump's capacity, the higher the pump's expected maximum efficiency. It is also worth noting that the specific speed at which optimal efficiency occurs varies with pump type. According to the Hydraulic Institute standard, a volute-type pump can attain maximum efficiency if its specific speed is close to 2,500 US units. A vertical turbine-type pump, on the other hand, may reach optimum efficiency when its specific speed is about 5,000 US units. Therefore, volute pumps selected for services with specific speed values that are not in the vicinity of 2,500 US units will probably have lower efficiencies. Hence, for a particular duty condition and pump type, the pump speed should be selected such that its specific speed falls within an optimum specific speed range in order to obtain the highest possible efficiency. For more details on the pump speed selection, you can read the full article on our website. The link to the website is given in the description. I hope you found this video informative. For more updates, please like, share, and subscribe to TechnoWorks.